looking forward to talking with you about that. All right, so I'm just going to jump right into the Mobile Science Labs team. So just to kind of quickly review our problem statement, our goal is to design a mobile science lab that transports experiments for rural schools in 4th to 10th graders in India in order to supplement the hands-on learning. So, you know, we're working to create our experiments this semester and a lot of exciting stuff. So just to kind of go over some of our progress recently, some of our main focuses have been working to expand our experiment set and kind of the range of people that it can get to. So especially with COVID and different things like that, we've kind of been working with different sorts of online experiments, things like that. So we finished up our phase 1 and 2 experiments, but now we're starting to work on video demos. So on the right-hand side of the screen there, you can see we've got kind of like an exciting little cover for one of our video demos. We're going to be looking to work on those a lot this semester, so that's really exciting. We'll be working on more experiments for phase 2, so kind of filling in the blanks where we're working really closely to supplement the curriculum and not replace things that we're not trying to create a new curriculum. So we're going to be looking at our current set of experiments and filling in the gaps, and then we're also looking to reaching out to local schools in America for testing. So we have some contacts that are at a school about an hour from here. So we might be working with them this semester to test some experiments. That's really exciting. Also, we've got a new team this year, the electrical team. So we will be giving you a high-level project overview for them, and then they've also been doing some solar panel and battery research, which we'll talk about a little bit, and they'll be working on that a lot more this semester. And then we'll be talking a little bit about our power requirements, possibility of doing an electrical vehicle, and all those sorts of things. All right, and I'm going to pass it off to Bree now to talk a little bit more about our project.
Yeah, so like Abby said, we're focusing a lot on our experiments this semester, specifically working on filming video demonstrations. So as a lot of the schools are still online and we're not quite sure when they'll be back in person, we want to make sure that the students still have access to doing that hands-on learning that they don't quite have. So this is a list of the video demonstrations that we are planning on filming in the next couple of weeks. And so these are experiments from phase 1 that our partners actually translated for us last semester, which is great. And then, like Abby said, we've reached out to a few schools in Indianapolis, which is, like she said, about an hour from here. Those are provided by our PhD student, Austin, who you guys met earlier. So that was great. And one of the teachers actually did reply to us, so we will hopefully be working with her in the coming months, which would be great. We're not sure if we're going to send them the video demonstrations quite yet or like physical experiments. We're going to keep planning that out. But that's really awesome that we have that. And then, like she said, we're also developing more experiments in phase 2. And so these are kind of more technology based. So they have more aspects of technology. Like one of the experiments, for example, is using a DMM. And then a few others have microscopes. So we're going to be continuing to create more experiments in that phase as well. So I'm going to pass it off to Quentin to talk about the Aero project.
All right. This is our potential aerospace final project, and we're focusing a lot on aerospace related topics that we've pulled from the different schools' curriculums. This includes drag, pressure, lift, stability, motion. We've got different experiments that kind of demonstrate each of the topics. We've got pressure, stability, drag, lift experiments. The whole idea is that the students would do these experiments, and then at the end of the year, maybe at their 10th grade year, they would do a final design project where they would either design a glider or a small plane, or maybe like a pressure-fed rocket. Ultimately, the goal of this project is to solidify a lot of classroom content and present a real-world application of the concepts that they've learned in the class, and hopefully kind of give them some interest in engineering. Ultimately, it's in the early stages. We're still working out a lot of details with our project partners, so a lot of it is subject to change. Pass it off to the electrical team.
All right, and for the electrical side, our overall goal is to provide solar energy to sort of power the smaller electronics and also allow for electrical scalability. For storage, so far, our plan is to keep the electrical equipment in a Vanguard case we have, and then the battery in its own case, just due to size, while the solar panel can actually just be left in the lot. This way, when transporting the experiments, you can actually just disconnect the solar panel, bring the 2 Vanguard cases into the rickshaw for portable power. Of course.
And then on the left here, you can see that block diagram of that high-level overview that we were talking about. So here you can actually see all the connections from the solar panel itself to the charge controller, battery, and then inverter circuit to give different DC versus AC loads. So that's just kind of a high-level thing about how power is actually going to go throughout the system. And then on the right, you can see some of the extras that we plan on implementing into the system if we have time or if we see an avenue that could support it. So since we might be using an electric vehicle, we could potentially supplement some of the EV's power. We also plan on having like an LED lighting system on the outside of the rickshaw, potentially having an identification locking system to maybe help with security. And then if there's time available, we might have like a 220 volt AC like outlet on the outside so people can charge things separately from the rickshaw. So, and then on the bottom here, on the bottom right, you can see what we're planning on purchasing versus designing ourselves. So the solar panel and battery we plan on purchasing just for usability. And then for designing, we plan on designing the controller, inverters, and the distribution network from the block diagram here. And then that is the end of Mobile Science Lab. So do you guys have any questions for our team?
Yeah. So I wanted to ask a question. There is echo coming from where. So I had an interaction with your Indian team, IIT Tirupati, and I made a comment there, which I'm asking you again. Some of the components for the school labs, are they available in local market in Tirupati? Have you checked those items?
Yeah.
Oh, yeah, I was going to say, so we're definitely looking into that. Especially, we actually talked with our partners this morning about some of the materials we had talked about using for the aeronautics projects and the planes and stuff. So yes, we're absolutely checking on that. We wouldn't want to implement an experiment and then not be able to use it there. So yeah, we'll be doing that as we go. And then, of course, before we send anything over, we'll be double checking.
That is one. The second aspect is that, it is important that the local practices, if they could be understood while developing the experiments, like for example, when you grow up in your country and your environment, there are certain practices played at home or in your neighborhood, and then you may feel that some of these experiments are relevant in a sense they are seen even as a child, but then in Tirupati it might be very different, and very different could be 100% different, but there could be some similarity. So maybe it will be important if you have looked, if you have not done that, that probably some experiences of when the child grow up there, what they see around them. Maybe some of the examples could be, if they are next to river, for example, or maybe next to sea, it might be good that they might be seeing that how the aerodynamics can be seen by them through a boat passing in the river or things. Maybe an example of that would be more relevant compared to if my home is close to an airport. So I could rather show an aeroplane effects there. So I would suggest if those kind of things can be taken into account, if not already done. Any comments?
Yeah, no, I think that's a great point. We were actually talking with our partners this morning. In the past, they haven't really worked much with us in designing the experiments. It was mostly us, and then we would send it to them for testing. But they actually expressed interest in helping us with the experiments this semester. So we'll definitely be working with them on that.
My last comment would be, since you are having this meeting with one of the Indian partners, so I would not mind, or rather I would love to see your Tirupati partner in our next WeLDER session as well. So if you like to invite them to share these presentations in this WeLDER session, we would love to see them in this forum.
Yeah, for sure. We'll invite them next time.
That's from my side, yeah.
All right.
Any other questions?
Yeah, one other comment is on supplementing the electric rickshaw power. Where is it that you intend to supplement the power? Is it going to be on the front wheel or one of the two rear wheels?
I'm sorry, can you repeat the end of that sentence? Sorry, cut off a little bit.
Yeah, like do you intend to supplement power on the front wheel of the rickshaw? I assume it's a three-wheel rickshaw.
We don't know yet. It's still
Okay.
we're still just talking
So
about.
just to let you know, the typical manual pedal-driven rickshaws have one of the rear wheels powered with the chain, and then there is a certain learning the rickshaw puller has, so how he can use power delivered to just one wheel to maneuver the rickshaw.
Okay, yeah, I
So
haven't looked into
when
that.
you're going to augment it, just keep that in mind, and you may or may not want to supplement the same wheel.
Okay. Yeah, thank you. That's a great point.
Yeah.
Okay, next, Suraj.
Yeah, any more questions or? And I think then we'll have one from IT Delhi team. Then we'll come back to Purdue.
Yeah, absolutely. All right, unless you have anything else for us, I'm gonna stop sharing my screen and then pass it off to whoever's next.
Yeah.
And thank you all of you who presented. It was very clear, crisp, and very time efficient. So you did a good job sharing what you did. Thanks.
Thank you.
Yeah. So Anushka, you can go ahead.
Okay. I'll probably share my screen first.
Yeah.
Is my screen visible?
Yep.
Okay, so hi everyone, I'm Anushka, and so this is a project that I'll be presenting, and it's on Bhilwa decortication. It's something that three of my friends and I worked on this summer. So,
So yeah, now it's.
oh, okay, is it visible now?
Yes, go ahead.
So just to set up the context a little bit, so basically Bhilwa is a fruit that's available, and um, we were working on finding an efficient way to extract the nut which is in that seed, the reason which is in that fruit. The reason for that was because the current practices that are being used for decortication are not that efficient, and I'll tell you the reasons why that is. So we researched a bit on what exactly the structure of Bhilwa is like, and what is decortication, what is the community where we're working is like. So the Nahar community, which is basically in the Betel district of Madhya Pradesh, which is a state in India, they are the ones who basically work with this, who work under this domain, and their major source of income comes from this. So moving ahead, we went over and we researched a bit about the traditional method of how they're decorticating Bhilwa. And that was, they sit in this really uncomfortable position against a stone, and they use a stone to hit the seed in order to extract the nut from it. They partially wrap up their hands, and the reason for that is that when you break the seed, when you break the fruit, you have a poisonous oil which splashes, and that oil causes a lot of bruises on your hands, and maybe even if it reaches up to your face, it can cause bruises over there. So for that reason, they try to cover themselves as much as possible. And the reason why they were using the stone is because it's a hard fruit. The covering is really hard, so you need a very rigid thing to break that covering with. So that was what the traditional method was like. So the problems that associated with this there were some social problems, and because of the injuries, because of the bruises, they were not really given a very good status in the society. People had problems regarding that. There were economic problems. This source of income wasn't very sustainable. It didn't give as much as the effort it required was. And then coming on to the health problems, of course, the poisonous oil, the posture in which they were sitting, all of them caused serious health problems to the people who were working. And then a little bit on why the mainstream decorticators couldn't work for Bhilwa fruit. So, a centrifugal impact decorticator, we searched on what the centrifugal impact decorticator does, what the parallel and tapered gap decorticators do, the bar and drum decorticator, and we concluded that it's basically the structure of Bhilwa that's the problem. Like Bhilwa, as you can see in this slide over here, Bhilwa has really varied structure in terms of length, in terms of the weak point where the person has to hit, or the machine has to hit in order to extract the nut. So Bhilwa can't be treated in bulk. Every seed has to be treated individually in order to extract the seed efficiently. So we tried to understand why the existing solutions are not working. The reason was they were not covered properly, so it wasn't really dealing with the splashing of oil, and they were not efficient in terms of the posture in which the people were required to sit while using them, or they were completely mechanical. So the people would lose their employment opportunity if it's completely mechanical. So in order to gain some more insights, we tried to approach the people who had made these machines, and we built up some reference from them. And then we started with the ideation process. So the ideation process, we built up around 3 models, and we understood where those models could go wrong, and these were these 3 models. And we ultimately came up with this one model, which was, as you can see, it's sort of in the form of a conveyor belt. And this is a power hammer, or a hammer which works on the same principles. And basically this is the holder, which I'll be explaining in further detail ahead. And then there's this glass box which covers during the point where the hammer hits the nut, so that the oil doesn't splash. So this is the conveyor belt over which our Bhilwa nuts would be placed on each of the holders. So holders will be placed on each of these 22 spots. And the frequency is going to be fixed on the basis of how much time the person takes to set up the Bhilwa seed onto the holder. And the holder is this portion. So this is the portion on which the person will be fixing the Bhilwa seed according to their experience which they've gained until now. And the inspiration was this from, the claw machines that we used to play with when we were young. And then because as I told, Bhilwa has varying heights. So in order to adjust the height in accordance with the hammer's hitting height, we took inspiration from a normal car jack. So, just on the principle that it works, they can adjust the height very comfortably so that the Bhilwa is hit at the right point. So just to go over the complete step-by-step procedure, basically the person who's handling the model is going to be setting the Bhilwa, and that person might be over here. The person is going to set up the Bhilwa, set the height, and that Bhilwa is ultimately going to enter this glass box. It's going to be hit by the hammer, and as it reaches over here, that person is going to drop it off. The dropping action, maybe I could, okay, well, the dropping action is sort of, it comes over in the form of an arc, and it drops it over onto this tray, and that's where we get the separated nut from. So this was sort of, and this is of course a recurring process, so sort of addressed a lot of the problems that we had identified earlier. It was preventing splashing of the oil, it was effective, it was dealing with a lot of capacity, it was easy, and it did not harm the employment of the people. So yeah. Any questions?
Yeah, any questions for her?
I was just going to say, this is a really interesting project. Thank you so much for sharing.
Thank you.
So can you talk about the output, throughput? How many Willow seeds per minute can be expected out of this arrangement?
Yeah, so as I mentioned, that has to be tested once. So at once, 22 seeds can be placed, but then we'll have to see on what the frequency of the revolution would be. So that depends on how much time a person is taking to set that Bhilwa seed onto the claw holder. So that is something that needs to be tested upon. But I think probably 40 seeds could be treated in a minute maybe, because I think 30 seconds is enough for them to set the Bhilwa onto one claw.
Thank you, Anushka.
Thank you.
I do have a question. My name is Josh. I'm a part of the BDT team, and
Okay.
I was wondering about the conveyor belt and the manufacturing of that. Like, how do you create the holder to like hold it in place? Does it open as well? So the hammer isn't hitting the holder.
Yeah, so basically the holder is just to hold the seat in place so that when the hammer hits, the seat doesn't really tumble upon. So that's what the holder is basically doing. And so I made a CAD also on this. Maybe I could show you so that it gives, just a sec. I'll just present again. Give me just a minute.
It's a very interesting project. I've not heard about this issue before.
Yeah, sure.
If someone wants to take it up from Purdue, you're welcome. We had proposed it last time as well.
I could just.
Yeah, go ahead.
I could just. Yeah, I could just share my screen just again. I just opening that link. Yeah. Is this visible?
Yeah.
Yeah.
Yeah. So this is sort of what the holder is going to look like. So this is where the claw. This is the claw where the seed is going to be fixed, and this is sort of what I was talking about, the dropping action. Does that answer your question, or do I need to answer something else?
No, that does answer my question.
Thank you.
Very interesting. Thank you for showing me.
Yeah.
Thanks.
Yeah. So next, Suraj.
Yeah, if there's no more questions, I think we can go back to Purdue for plug-driven tractor.
All right. Do you all want to come up and introduce yourselves, and then we'll pull up the presentation, get you set? All right, they're coming up here. They're all gonna come introduce themselves really quick. Yeah.
Hi everybody, I'm Radonk Sharma. I'm returning guest, but recognize me. I'm the design lead of the BDT team, and I'm a senior in aerospace engineering here. So I'll have the rest of my team introduce themselves.
Today you are not recognizable with your mask, but I remember last semester.
Yeah, unfortunately, we're in person now. That's great though.
Yeah, go ahead.
Hello, my name is Josh. Josh Williams. I'm a freshman at Purdue. I intend to study aerospace engineering.
Very good.
Hello, I'm Shama here. I'm a first year undergrad student at Purdue, and I hope to study computer engineering.
Oh, great.
Hi, my name is Ansi. I'm a first year engineering student at Purdue, hoping to go into aerospace engineering.
Okay.
Hi, I'm Sonia. I'm also first year engineering at Purdue, hoping to go into biomedical engineering.
Hi, my name is Louisa. I'm a first year engineering student, and nice to meet you.
Thank you. I thought the introduction was done, wasn't it?
No, I think one team was to be introduced as they were going to.
Right. Okay,
So there's a little bit of overlap, yeah.
Hi, I'm Anisha Patel. I'm a second year student and I'm studying industrial engineering.
We met you last semester also, right?
Yes.
Yes.
All right. I'm Miles. I'm a second year as well, and I'm studying aerospace engineering.
Okay, good. So lots of aerospace engineers are here in this group.
Hello, I'm Louisa Davis. I'm a first year in first year engineering, and yeah, I'm excited to work with you all.
Thank you.
Everybody? Okay, all right, I'm gonna cue up their presentation and then we'll get going. Let's see. Can you see this? Okay,
Yes.
Okay. All right, I'll let Blunter and Tractor take it over. All right, yeah, make sure you step in front of the camera so they can see you. Can you do it just as good?
Hi, so our problem statement is to create an ergonomic and cost-effective bullock-driven tractor that can efficiently lift farming attachment in order to aid rural farmers with cultivating rice and wheat. So these are our project requirements. One of our main requirements is to make it affordable for farmers having minimal wages, while also making it competitive in the Indian market. So we have been given a value of 10,000 rupees to 25,000 rupees. Another requirement is the ergonomics. So it should be, the seating should be comfortable, and it should work for at least 8 hours without breaks. So it should also preserve the energy of the bullock. Another one is the lifting mechanism. It should be able to lift 30 to 35 kilograms of weight easily, and should take away the stress from the farmer. Another one is the ease of use and maintenance. So it should be able to be used by farmers who are not properly trained, and it should have a lifespan of 5 to 10 years. For durability, we have used steel to make it, and for this, it should also be versatile. So it should work to plow rice and wheat. So it should go as deep as 1 inch for rice and 2 inch for wheat. And it should be able to work on different soil types and different environment.
So let's kind of move on to our design overview. You guys have seen this general overview before, but this is basically the CAD model of our entire tractor, the way that it stands currently. I do want to go into just a little bit more depth about the additions that we've made since the last time we've spoken with you guys. We did add safety guards, which you guys did see the safety guards on the pulleys that kind of exist around the moving mechanism of the tractor last time, but this time we've also added safety guards to the lever arm that's going to be fluctuating underneath the seat. So overall, we believe that these changes will make the tractor a lot safer to use for the average farmer. And one focus that we have as far as our conceptual design goes is being able to flesh out this locking mechanism, because a big part of our tractor is going to be able to adjust, not just be able to dig a plow into the soil and then be able to pull it out and then be able to move the tractor or turn the tractor, but also be able to lock in various positions along that path. So this is not something that we have in the presentation, unfortunately, but next time we will have like more well-defined models, which will actually be able to predict for us just how much pressure on the foot pedal that's going to translate to the rotation of the lifting mechanism. So there's something that we're working on in MATLAB, and we will hopefully have it for you by the next presentation, so we'll get to see that in a lot more detail. But for now, we do have the CAD model, at least the first look CAD model for it. So there's kind of the conceptual design part of the project, and a big part of our project, a big chunk of our work this semester specifically has been actually prototyping our full-scale steel prototype. So I'll pass on to Anisha to kind of go into more depth about that.
So last semester, you've seen this design of kind of showing that we did a little wooden model of just a lifting mechanism to prove that our design worked, and that it kind of, the video is not working, but we wanted to build a mini scale model of it to make sure everything worked properly, could lift up the weight. So in the video on the right, it was supposed to play showing kind of that we had an attachment, a weight on the back to mimic the plow attachment, just a regular weight, and it was able to lift it up smoothly with not much ease needed. So next over here is kind of the main assembly parts, or balloons and parts lift of kind of the different things we need to do, such as the frame, the wheel, the seat, the foot pedal, the pulleys, and the rope. Everything's kind of needed in there to get it all working together. And then overall, here you can see the physical prototypes. So we've got mild steel, we have the pulleys, the wheels, and all the kind of different components that we need that we feel that India will be using on the same way to when they remake their physical prototype over there. And then for manufacturing, we kind of have these detailed designs of each of the components. So you can see on the left is kind of the base, and then in the middle is the weight in the back. And we can see that kind of has a dimension, and this is what we've been using when we were building our model downstairs in the lab, and still using this to help kind of scale it, and hope to have a refined version of these once we kind of work through all the kinks and once we give the final design to you guys. Louisa and Miles will be talking about machinery.
Okay, so for machinery, we have generally just used two power tools in the EPICS lab. We are using the cutoff saw and the drill press. With the cutoff saw, we are just cutting the mild steel bars and our angle irons. And so that's been pretty efficient so far. With the drill press, we are just creating holes in the bars and the metal brackets to fasten them everything together. So our steel prototype is using hollow mild steel bars for the frame. We were originally going to use aluminum because it's just more accessible here in the United States, but with our project being like for Northwest region of India, the mild steel frame is just more accessible there and cost efficient. We are using bolts and angle irons to hold everything together. We were considered welding, but because of our limited lab space, and since we're not like really testing for the structural frame integrity, we're mostly focusing on the lifting component. The angle irons are doing a good job. So we also added a metal bracket for like added reinforcement. The angle irons were strong, but we just wanted to make everything a little bit more tight and sturdy. And we are about to begin manufacturing our lifting mechanism. For that, we are considering welding. Just because of it's like a smaller component overall and there are smaller angles. So the angle irons would not be as effective and we want to make sure it's super sturdy so we can test it properly.
All right, so this is how we plan on testing our tractor. Our first test is the component test. This is a test that'll span pretty much the entire testing period. And this is where we're going to be testing the individual mechanisms. So that means the lifting mechanism, the foot pedal. And this gives us the opportunity to catch these failures before something major happens with them. The next two tests, the static and the assembly test, those are going to start at the beginning of our next semester, so spring 2021. The static test is we're going to test how the tractor operates and interacts with the lifting mechanism while seated. Right now, that's without the wheels, hence the static test. And this will help highlight any ergonomic issues and if any of them exist. So the next test is the assembly test. So we'll fully assemble the tractor with the wheels. And then this will highlight the dynamic issues if any exist. And the last test is the farm test. This is still a little out in the air, but right now we are planning on bringing the fully assembled tractor to a farm and having it be pulled by a horse. So we know that's not an exact replica for a bullock, but we think that it will help us understand the ergonomics and the movement of the tractor. That will definitely help us. And then the jout of the animal will be incorporated and the tractor will be tested on local farmland. So our immediate next steps right now is to finish manufacturing the prototype. That means adding the seating, the farming implements, and as you saw earlier, the locking mechanism. We're going to just definitely refine that until it's perfect. And then the prototype testing, that's what we saw on the last slide. This is going to start this year and then end next year, hopefully. And then overall, just to continue to refine our CAD model based on the physical prototype merits and flaws. So that's just an ongoing process that'll end when the project does. And then that's what we have. Are there any questions?
Yeah, so I think progress is good in a sense. You started manufacturing it, but I have a suggestion for those who like software. There is a CAE tool called ADAMS, Automatic Dynamic Analysis or Mechanical Systems. I'm pretty sure that Purdue Aeronautics or Mechanical must have it. So you may try to do the complete multi-body simulation of the tractor. Some of you may consider it and may find it interesting.
Sorry, can you repeat what that was called?
ADAMS, ADAMS. Automatic Dynamic Analysis of Mechanical Systems. It is by MSc Nastran product for CAE motion simulation. So complete tractor can be simulated in that environment because now you have the CAD drawings. You just have to place the joints to have the motions. And then you can see in a software environment that how much the forces are coming, how much of the accelerations possible you may do in a virtual environment, which they use the term called virtual prototyping.
That's very interesting. That's something we'll definitely look into.
Yes. Yeah. Okay.
Thank you.
One comment I'd like to make is in terms of the final test plan to prove that this does the intended job. Is there any understanding we have right now about how many acres of farmland this bullock-driven tractor should till in a 2-hour period or a day or anything of that? I mean, just to see the relevance and the competitive value of what we're doing.
Yeah, so we actually, I guess we don't know that yet. I think that'll be a useful value to have. I think the majority of our focus so far has been testing the individual components of the tractor in kind of a clean setting, I guess you can say, aside from the farm. So we will definitely have this conversation, I think, later, and maybe get this value figured out when we actually get closer to our farm test.
All right,
So
great.
Upinder, the comment here is they have picked up this problem from our root IIT Delhi, where Davinder was very closely involved. So if Davinder has any answer to Upinder's questions, maybe he can quickly answer.
Yes, I would like to tell you that sorry that I delayed in sending you the dimension of that tines you have asked for. In coming week, I'll definitely try to send you the dimension of that tines, which you are asked us maybe in the last meeting. Secondly, I will share the data of how much a bullock-driven tractor till land in terms of, I mean, how much area a bullock-driven tractor can till. That data I will also share with you soon. So sorry on that. I'll be sharing that data soon.
Good.
It's fine. Thank you.
That's fine, Davinder. I just wanted to kind of bring perspective that see currently the technology of using a single you can say plow which is just pulled by bullocks without any machine. So one reference point is that. So how much acreage can be tilled using no contraption at all? And then there is the mechanized tractor, where you can have maybe 1 acre done in 45 minutes. Some point of reference there. So the solution that is being developed probably will lie somewhere in between.
Yes.
And my kind of question was to encourage you to look where the value proposition best fits in. And it's fine if you need some more time to get that data, but I think by the time the prototype is ready, I'm sure you'll have that data. Thanks.
I would like to add one thing more, that the data might be for a single plow, but our bullock-driven tractor is a multiple plow. So I need to consult Professor Ajit. Actually, the delay was because I tried to contact Professor Ajit, who actually did his PhD before he became a faculty in IGNOU. So please bear with me. I'm in constant. I'm trying to be in touch with him because he has done extensive job in that. And if whether he has used multiple plows and if he has some data. But during our testing in Haryana, we have some data which I will share with you all guys. Thank you.
Thanks, Davinder. Yeah, please proceed.
Yeah, any other questions? No.
No, go ahead.
Yeah, so then I think we'll go to our final presentation of the day. Vending cart team who will be presenting, Palak.
Hello everyone.
Hello. Okay.
Yeah,
Hello everyone.
Palak, you just carry on.
Okay. Hello everyone. Myself Palak and Gaurav is my teammate. We are from team 14 Ruteg.
Please turn on the camera, Palak.
Okay, sir. Yeah.
Go ahead.
So hello, myself Palak and we are both BTech second year students at IIT Delhi. So Gaurav will share the screen.
Yes, I'm sharing. Is it visible?
Yes.
Yes.
Put it on presentation mode. Big. Actually, this is a PDF. Make it big.
Yes.
So we made project on improving the vending cart. We basically addressed the issue of rotting of fruits and vegetables due to the increase in temperature. So which causes a great loss to the vendors. So we
Can
made.
can you zoom
Hello?
the F a bit?
Zoom in. Make it 50%. As I see 33 only. Yes. Ah, that's better. Maybe 60%.
So, as the excessive temperature and harsh climatic conditions causes the fruits and vegetables to rotten and shorts their life. So mainly what the vendors use the method is they sprinkle water on the fruits and vegetables to increase their lifespan. But it is not the correct way. Like this, because of the temperature and moisture, the life of the product becomes less also. So for this, we decided to redesign the carts with a temperature regulator system included in this. So we redesigned the cart, and in that we have added a system which will regulate the temperature, and also we have made some attachments in it which makes the vending cart more appealing for the customer and the vendor. So now Gaurav will explain our solution. Over to Gaurav.
Gaurav, little slowly. Going too fast. See the slide change.
Yes, sir. So in our this conceptual design, we just use thermal insulation technique.
Not audible clearly, Gaurav.
Sorry. Now in this our conceptual design, we had used thermal insulation technique for just cooling down and saving our products from heat and this enormous amount of drastic climates. So in our so in traditional vending carts, the thing is that the vendors keep these fruits and vegetables on a flat horizontal surface of the vending cart. Now and then they sprinkle water on it. So in our design, we constructed our vending cart in such a way that we used some cubicle boxes whose boundary is hollow. And in that hollow boundary, we will put some cold water. And that cold water will make the temperature inside that cubicle box a very much less than outside temperature. Approximately, we can take 20 to 25 degrees Celsius in in hot climate. And this temperature is suitable for the storing of fruits and vegetables. Now, in the peak of the summer, when heat wave is very much high, we know that the cold water will obviously the temperature of the cold water will rise up and that it will become somewhat normal or hot water. So from to prevent it, we used that thermocol sheets and covered whole of the vending cart these boxes with thermocol sheet, which is a very good insulation, and which can make temperature of the cold water rise up very slowly. Now, this is our detailed explanation of that box metallic container which have a hollow boundary in between and in which we will put cold water. Now, uh, in this present solution, we have majorly two problems. The first problem is that as we are putting these hollow boxes and making a big cuboid, there is very much lack of oxygen because only the top surface will be uncovered and the fruits and vegetables which are present at the bottom of the surface will not be able to get proper oxygen supply. So, and the second problem is that as the cubicle as the container is vertical, the customers are not able to see properly what is kept inside them. They have to come close to the vending cart and then look inside what is kept inside. So it will give a bad impression on what on the seller. So for the solution of the first problem, we just put some holes at the bottom of the metal sheet so that there will be a proper supply of oxygen and the fruits and vegetables will have a good lifespan. And for the solution of the second problem, we just tilted the vending cart. And by tilting the vending cart, it gave us some more advantages also. The first advantage was its look got beautified. The vendor could present the fruits and vegetables in a good way, and the customer will also be able to see properly. And the second one is that beneath that cubicle boxes, we will get a enormous amount of space, and that vendor can use this space in many ways he want. He can store his supplies of the fruits and vegetables. He can store his bottles and etc. So this was that all. And third one problem was that we are not having any place for the vendor to sit down and take rest. So for that we designed a foldable stool at the right or left side of the vending cart. And this foldable stool, when it is unfolded, vendor can sit on, and when it is folded, I think in this situation, folded stool, it will help the vendor to some protect and push. We can also add some that pushing mechanism also in that side. It can be used. We had not implemented in this, but it can be used. Now, this is our improved design of unfolded and folded stool both. And now, how a solution is better than existing solution. Now, first point is that it will obviously increase the lifespan of the fruits and vegetables which the normal vendors give. And second one is that it will protect the fruits and vegetables from heat and dust, because in the normal vending cart they are not having any boundaries from the from left to right side, means they are only covered from bottom surface. And in our vending cart, the fruits and vegetables will be covered from the bottom surface, from the left side, from the right side. They will be only open from the top surface, so it will be protected with heat and dust. And the third one is that it is also cost effective, because it can be built from that recycled objects, like that oil containers and all. We can build it. And this is our final design, some of the CAD model views of a final design. So thank you. Any questions, please?
Any questions for the team?
Well, just a comment that do not always believe that lack of oxygen is going to mean the vegetables will go bad. Because sometimes it's conducive to lower the respiration of vegetables to prolong their life. So just do some research. You'll find reference data in ASHRAE about the most desirable condition. But yeah, the direction is good. You're looking at cost. You're looking at functionality. You're integrating a folded stool. So.
So the problem you stated, we can upgrade the vending cart in such a way that we are using 2 to 3 boxes, or we are using some 4 boxes. We can create one box with no holes at the bottom, and see if there's some fruits or vegetables which require very less oxygen. We can put them in that one, and put other in other boxes. That's all.
Other side.
I'm not sure if you guys have ever considered this design. I know there was a local farmers market, and what they did was at the bottom they had, I'm not sure how available it is, but they had glass at the bottom. And what they did is they had 2 layers, and what they did is they cooled it from the bottom on the first layer, and then to protect it from dust, they had a second layer that essentially protected it. Have you guys ever considered that design instead of having one metal sheet, like 2 metal sheets with the thermoregulators underneath the first sheet, but protected by the second?
Probably not. Probably not. Please answer, Gaurav. Did you consider that?
No, sir.
Okay. So maybe if we can have some references, we would look into the matter, because we have taken up a big project to successfully implement that. We would like to look into that design also.
I can see what I can do, and I might be able to find a picture of it.
Yeah, that would be nice. Yeah.
But just to understand it a little more, so you're saying glass, like transparent or translucent glass at the bottom, and then
yes.
a layer of air in between that glass and the next sheet of glass. It probably acts both as insulating as well as protection from dust.
Yeah. So I'm not really sure how it works. So, but they would have a sheet underneath, like a first sheet and then the second sheet. The second sheet would have holes to allow oxygen, and then on the sides they would have slits, similar to like air filters. So there would be air filters on the side, a piece of glass or metal underneath, and then another layer with holes to allow the oxygen to come in, and the regulators. And the reason why they had the second sheet is because they had a lot of heat loss due to the holes. So that way that there was a second layer protecting, similar to a spacecraft. They had the layer outside protecting them from space, and then the inside layer keeping the oxygen in.
And have you ever purchased vegetables or fruit from such a vending cart?
Yes, I have. It was.
So when you pick up the fruits and vegetables, are they cold? Like, are they refrigerated and they've been just transferred for short duration into this cart?
Yes. Normally, there's always the issue with the top because they're exposed to the environment. However, overall, as you go down, it usually keeps the temperature inside. When you obviously, with heat induction, the temperature, if you cool it from the bottom, it moves up. I don't fully know how that works, but I can look into that.
No, that's fine. We're just trying to understand the practices because in India, a lot of fresh produce is going onto the vending cart. So it's not chilled or pre-cooled. And I was trying to assess whether in the US the practice is similar or it is different. So from the farm, it is probably, that's my guess, and it is pre-cooled, refrigerated, and then brought into a warehouse from where it comes onto the cart. So I was trying to just find out if you're picking up fruits and vegetables that are relatively lower in temperature than the ambient, then that process is being followed. Whereas in India, it is primarily from a fruit and vegetable market. It is direct from the farm to that market and picked up by the vendors. So it's at ambient temperatures. But thanks. I think maybe if you find some more insight, we can discuss it offline. Yeah.
Yes. I don't know the vending process for America. I do know that they were normally picked that week at the very least and then sent to market on a Saturday.
Good.
Yeah. Thank you.
Thank you. So, what's up? Done?
Yeah. Any more questions for vending cart?
No vending anymore. Vending stop.
Yeah.
Yeah,
So I think we're done.
So thanks. So I think from the EPIC side, there are many freshmen has been introduced, and so in case you want to pick up any problems, so maybe Suraj can share some of the latest projects. If EPIC's new freshmen want to take it up, I remember last year, last semester, one dust protective project was taken up. Maybe it's not being continued this year because today I don't see any presentation unless they come next time.
Professor, I can't hold myself back from proposing one project which I discussed once with you. Some kind of a device that can be used to spray insecticide. So
you have to write to Suraj because just over the desk or over the terminal may not be very nice for them to understand, and we do not know how many of them. Typically, they have many students registered in these EPICs, and some of them take India-centric projects, and that's why they call it EPICS India Group actually. So what
since I heard aerospace so many times, so I thought getting a drone into the picture and having their minds work around a drone carrying a certain volume of pesticide and then helping the farmer spread it more evenly would be a
no issue. So you can just write to Suraj and he can share with them. So let's hear, Gabriel, what is in your mind? Is that okay that we send you the list in case some people are interested? Oh, hello. How are you? Nice to see you. So it's we have another professor here. So nice to see you. A long time. Yeah. How are things? Bill?
Yeah, so I'm Professor Oakes, the faculty advisor for here. So the teams, when they started this semester, they looked at the work that we had to do and decided that they could keep everybody busy on the projects that they had. We would be interested in your projects, honestly, and the idea of the drones with the insecticides and those.
Okay.
would be something we'd be interested in exploring, because we do have a lot of students in aerospace, and we don't have enough projects to do with those.
Okay, so we'll pick it up.
Yeah, so we'd be interested in that. I don't know if we would pull the students from the project, but we could look at that. We could also look at recruiting some older students from aerospace for next semester too. That if we had something that we could propose, it's right. It's what comes first. That in the United States we say, is it chicken or the egg? It is. If we had a project that aerospace students could work on, that we could actually recruit some other students to get that.
Okay.
So so there would be interest over in that. So we'd be interested in that. I don't know if we'd pivot right now, because I'm looking over at the mobile science lab where the aero students are, and they've been looking at, are there things that they can do with the mobile science labs to incorporate some of those concepts? But yeah, we'd be interested in that. And if there's students on your side that would be interested too, that may be something that we could explore for us for the next semester. When is your semester? Have you started your semester? Or I know in the South they haven't.
We're in the middle of the semester now.
Okay. The schools I know in the South have delayed their start.
Okay.
So, yeah. Okay.
What we'll do is, we spoke last semester as well, a project done by 2 sets of people from 2 parts of the world, actually, right? So what Professor Godara suggested, and some of the others, we'll see if we can get a counterpart this side as well, and see if this mix of students can do some projects next semester, January onwards.
Okay.
Yeah.
That sounds good.
Yeah. And for the next meeting, I suggest maybe 12th of November. Does it sound good?
When did you suggest again?
12th of November.
12th of November, Friday.
That's a Friday. Can I get back to you on that? I need to double check.
Yeah, this
So
is tentative.
Okay, so our design reviews are after Thanksgiving.
Yeah. So I don't think it should.
That should work, right?
Yeah.
Let's give you a tentative yes, and we'll confirm.
Yes.
But I think that should work. Yeah.
Yeah. And just an information, the bill, one of my PhD students will be joining Purdue for a year under the India Purdue program. You may not be aware of it. Indian government has a program with the Purdue where 25 research students, PhD students, can join Purdue for a year. And my PhD students will be joining Richard Wiles. He is in the medical robotics domain, and to spend 1 year from January. So in case some information in the form of hardware needs to be carried, for this EPIC STEM, for example, I can request him to carry some samples or some material if required. So we have enough time, 2 months. So just keep it in mind.
Okay, excellent.
Yeah. So if we're done, Gabriel, so thanks.
Yeah, thank you so much for meeting with us.
Yeah, so join you in November. Bye. Thank you, Godara, and thank you, our team.
Thank you. Thank you, Purdue team. Thank you, everyone, RUTAC team. Thank you, Rosa.
Thanks.